On the previous slide, we discussed the fate of a system, a gas in a cylinder piston assembly, as it is moved from a low temperature environment into a high temperature environment. Heat was transferred from the surroundings into the system because the boundary between the system and the surroundings, that is the cylinder, was made of metal, a good conductor of heat. When heat can be exchanged between the system and its surroundings, we say that the boundary between the system and the surroundings is diathermic. In my notes, I represent a diathermic boundary in yellow. What would happen to our gas if the cylinder, instead of being simply made of metal, was thermally insulated by a thick layer of styrofoam? Well, nothing would happen. Transferring the cylinder from the cold to the hot surroundings would not trigger any process because heat cannot be transferred from the surroundings to the system. Hence, the system's temperature cannot increase and the volume remains the same. In this case, we say that the boundary between the system and the surroundings is adiabatic. In this class, I will represent an adiabatic boundary using the color green. Heat can be associated with a variety of processes, such as chemical reactions, phase transformations, or mere changes in temperature. When the boundary between the system and its surroundings is diathermic, the heat is indeed exchanged between the system and the surroundings. We use specific terms to identify whether heat is transferred into or out of the system during the process. In thermodynamics, we say that a process is endothermic if heat is transferred from the surroundings into the system. In contrast, we say that the process is exothermic if heat is transferred from the system into the surroundings. Students in biological sciences should not confuse the thermodynamic usage of these terms with the biological one. In the life science, the metabolic term endothermic refers to organisms which generate heat from within to achieve a proper body temperature. In contrast, ectothermic refers to organisms which use the heat from the surroundings to reach their normal body temperature. So, the biological and thermodynamic uses of endothermic are actually opposite to each other. We said that a process is isothermal if the temperature of the system remains constant during the process. This can often be achieved by immersing the system in a very large water bath kept at constant temperature, and by ensuring the system has a diathermic boundary. We say that a process is isobaric if the pressure in the system remains constant. This condition can be achieved by ensuring that the system can be freely expanded or compressed, so as to ensure that the system's pressure remains constant and equal to the external or surroundings pressure. Finally, we define isochoric processes as any process for which the system's volume does not change. In the second lesson of this chapter, we will talk about isothermal compression or expansion of gases. We will also discuss isochoric or isobaric heating or cooling of substances.